All right, so we're just gonna get started. Hi everybody, and Shema kolece, so tam? All good? All right, so my name is John. I'm an iOS developer at Hyper, and I'm really excited to be here today to talk to you about API design and how I think that everyone in this room and everyone who works on apps and writes code every day is in fact an API designer. So when we think about APIs, what we normally think about is we kind of use them to draw this line between our app that we work on and kind of the underlying systems that it uses. So that would include things like the SDK that we're linking against. So in the case of iOS, the iOS SDK or the macOS SDK, as well as any frameworks and third-party dependencies that we've pulled in. So that would include open source frameworks and SDKs that we use from third-party libraries. As well, of course, as the standard library of the language that we're using. So in the case of Swift, that would be the Swift standard library. And of course, it's really important to think about this API line and to manage it in a good way, because we don't want to... Whoa, what happened now? Microphone? I can just be loud. Oh, there you go, it's back. Great. So of course it's important to think about this API line and to manage it in a good way, because we don't want to end up in a situation where we're using the SDK in an unsupported way, which breaks every time a new version of iOS comes out. And we want to make sure we don't end up with 1,000 different dependencies and frameworks in our app. And we want to make sure that we're not reinventing the wheel and that we're actually using all of the features that the standard library has to offer. So this API line here is really important that we manage it in a good way. But there also exists so many other APIs that we also have to manage and think about. And those exist within our own app. And that is why the title of this talk is Everyone is an API Designer, because we all work on apps and we all design APIs every day. So we might not always think about them as APIs, but we have so many different types of objects in our app, from controllers to models, and we might be using things like managers and delegates and observers. And having these objects talk to each other in a nice way and setting things up with good, stable APIs can really help us achieve a much better architecture. Because what so many talks have been about, both at conferences and videos you watch online and blog posts you read, really what we're looking for most of the time is different tools and techniques to help us avoid a situation like this, where we have this crazy spaghetti code with crazy dependencies going all across the place, back and forth and sideways. We want to make sure we avoid the situation, and API design can be a really great tool for doing just that. So today, I want to talk about 4 different characteristics that I think that great APIs should have. Now, important here is that we call them characteristics, not rules, not one truth, the only thing that matters, but rather guidelines and characteristics that we're kind of looking for when we are performing our API design. So let's dive right in and look at the first characteristic. And that one is that great APIs should be contained. Now, we talk a lot about containment and separation of concerns, and that is really important when it comes to building great APIs as well. So in this talk, I will show you a lot of examples, and we're going to take a look at a lot of different code examples taken from real-life situations. And we're going to go through it quite quickly, so I'm going to make sure to post these slides and all the code examples as well after this talk also. So, what do I mean by contained APIs? Let's start by taking a look at an example. Here we have a profile view controller. It's just a view controller like your standard run-to-the-mill profile view that has a header view that can display the user's profile in some way. It has a label for the user's name, and it also has a button that enables the user to log out. So it's just a standard view controller really, and in standard view controller fashion, we are using optionals here for all of our subviews that we then override load view, and where we then assign these subviews and we set up relationships. Like in this here example, we are setting ourselves as the delegate of the profile header view. So just by looking at this code here, it might not really look like something is wrong. In fact, it looks extremely standard. It doesn't look like something pops out that, oh, this is clearly a mistake. But with this kind of setup, we can actually run into some really tricky problems. to show you what I mean, let's take a look at now where we are actually using this profile view controller at the call site. Here we have a function where we can respond to whenever the user unlocked some form of premium subscription in our app. So this function gets run whenever an in-app purchase is completed. And what we want to do is that we want to assign a new special header view to this profile view controller to show the user some appreciation and say, well, thank you for giving us money. Here you go. Here's a fancier UI for you. So this here function here kind of shows us a little bit that we have a bit of a problem when it comes to our API. Because what we're doing here is we are reassigning the header view that, if you remember from the previous slide, we set it up in load view of the view controller. And more importantly, we assigned ourselves as a delegate. So what happens when we then reassign the header view? Well, the delegate relationship is lost, which will mean that our app will start becoming unresponsive to events, and we will lose things. And this is kind of a very bad situation to be in, because what's happening here? Well, the user is unlocking a premium subscription and giving us money, and we are responding with a bug. Not very nice. So we need to fix this somehow. How can we do that? Well, we can start to saying things like that. You can't use the API like this. You know, that's not a supported way to use the API. The person who wrote this code clearly did something wrong. It's not my fault. Well, that is one way of doing things. You can try to be the code police, look at every pull request that comes into the project and make sure no one uses your API in the wrong way. Well, that's very time consuming and not very nice to your coworkers. Should we instead try to think about API design in a way that really prevents these situations from happening in the first place? And one way to do this in this example is to go back to our profile view controller and change things a little bit. Well, first thing we're going to do is we're going to, instead of having all these subviews be public and part of the API, we're actually going to make them private. That way we can assume more things about them, we can have full control over what happens to them, and we're not exposing and leaking implementation details outside of this profile view controller. So that's step number one. But we still need something in order to be able to assign this special header view that we had to begin with. We need a way to style this profile view controller in a way that enables this premium use case. So we can't just lock things down and leave it at that, because that's going to cause other problems. What we need to do is instead provide an explicit API for styling this view controller. So in this case, we're going to add an enum, which consists of two cases, which corresponds to two different themes. And then we're going to add a style API that enables other code to call into this profile view controller and restyle it for the premium use case. That way we have an explicit API that we can test, we can verify that it works, and we're also still fully in control of our own subviews. We don't have to worry about other parts of the app modifying them in a way that's not supported. Now let's take a look at another example. Here we have another view controller. It's called a list view controller here in this case. And this one here, it takes a core data context as part of its initializer. Now this here is already a step in the right direction. We've started using dependency injection instead of relying on singletons and globally shared states. So that's good. But it's still kind of a little bit of a problem. So what's the problem here? Well, we have this view controller here, but most likely it's not alone. How many view controllers have you guys worked, or how many apps have you guys worked on that just had a single view controller? Not that many. In fact, we usually have lots of different view controllers in our app, and when they need something like the database, like in this case, the core data context, we usually need to inject it everywhere. Every single view controller needs to take this core data context and use it to load and save objects. But should a view controller really have to be aware that we're using core data in the app? Does the view controller really need to rely on core data as a concrete implementation? Well, not really, because the only thing the view controller really needs to know is that it can load and save objects from somewhere. It shouldn't really need to know about core data. So we can do things in a different way, which will help us a lot in the future when we might want to change things. For example, let's say we go to a conference and we hear someone talk about this new cool Realm thing, and everybody's raving about Realm. It's so amazing, it's so fast, and it's so cool, and we want to try it out. But if we want to migrate this app to using Realm, it's going to be a huge project because all of our view controllers rely specifically on core data. What is a much better approach is to create a more contained API, which in this case we're going to call database. It's just a protocol that just defines the API that any view controller can use to interact with our database. It can load objects and it can save objects, and that's really all it needs to know. And what we can then do is we can add extensions for both core data and Realm to actually conform to this database protocol. That way, we are free to change things without having to refactor the entire app or rewrite it from scratch. And we can be a lot more dynamic in the future when something new comes along. This approach and this way of defining contained APIs also has a really nice side effect. And that is that it makes testing a lot easier. What we can do is we can not only have different implementations of this in our production code, we can also have different implementations for our tests. So in this case, we're going to create a mocked object that actually conforms to this protocol super easily that we can just inject in our tests to be able to write tests much, much easier. So that's a nice side effect. So what we can do now is we can just go back to our view controllers and then simply make them take an object that conforms to database instead of relying on the concrete implementation, which will set us up for the future in a much nicer way. So I think that great APIs, they should be contained. They shouldn't expose their implementation details. They should keep them private. This removes a lot of confusion, and it really reduces this risk for invalid use, where you don't have to play the code police, you don't have to rely too much on code reviews to ensure quality. You can instead have the compiler do the work for you. Protocols are a really, really great way to define contained APIs, because they can have their underlying implementations easily changed. We don't have to refactor our entire app to move to a new implementation. So that is tip number 1, create APIs that are more contained. For tip number 2, we're going to talk about conversational APIs. Now, conversational APIs is not really a new thing. In fact, it's been along for quite a long time. Even if we go back to Objective-C, I know Objective-C, we kind of now look at it like ancient Egyptian language, right? Like hieroglyphs or something, but it's still around, it's still a cool language. And in Objective-C, we had this long tradition of making these more verbose conversational APIs and method names, like string by appending string, right? It kind of reads as an English sentence. But of course, doing things this way and kind of following this tradition, you can sometimes end up in funny situations where maybe things are a little bit too verbose. And this is something we can sometimes look at and have some fun. So we're going to take a look here at a class from AV Foundation. This is called AV Capture Movie File Output. If you thought that was verbose, wait for it. This here has a real method name in AV Foundation that is called records video orientation and mirroring changes as metadata tracks for connection. Wow. Whew, that was hard to read that. So of course, like, method names can get a bit too long and it can sometimes feel like you're reading a book. But on the other hand, we can also go too far in the other direction and say, okay, let me imagine as if I'm writing code on paper and I need to save trees. So I'm just going to make everything super cryptic, like this from CA Transformed 3D from Core Animation, which is an initializer that just takes things that's called M14 and M33. And of course, if you're a mathematic matrix specialist, maybe this makes total sense to you. You can read the matrix. But for mere mortals, this probably looks pretty confusing. So what we're looking for really is to strike this nice balance between having too much verbosity and still conveying enough information to enable our APIs to be used in a good way and to not be misunderstood. Now, when we're talking about API design like this, it might sound a little bit just theoretical, like we're just talking about it for fun, but it has some really practical implications. For example, in the Swift standard library between Swift 2 and Swift 3, there was this massive exorcism of verbosity, where before Swift would just import Objective-C's APIs word by word, and now it imports them a lot smarter, and it removes verbosity, and it makes it much nicer to use so that we can use dot syntax for enums, and we can remove a lot of the extra words that we before had. So we can read this API here like JSON object with data and options. So it becomes more clear and easy to understand. So how can we apply this way of thinking in our own code? Well, let's take a look at another example. Here I have yet another view controller. You know, that's what we do all day, right? We just write view controllers. And this here is for an action sheet. So you can imagine here that we are presenting some form of action sheet to our user, where we have different buttons and different actions that they can tap. So in this case, we have an API that's called add button. It adds a button to the action sheet. And there's this Boolean here, dismiss, which the intention of it is to enable the user to tell us whether they want the action sheet to be dismissed when you're tapping a button or if it's just a normal action. So this again, maybe just looking at the code, it doesn't look wrong or it doesn't stand out. But if we move over now and take a look at the call site where the API is actually used, we can see that it kind of looks a bit strange. And that is always a good thing to do when you're designing your APIs. Always look at the call site because that's what matters the most. Here you can see when we read this, it says action sheet, add button, button, finish button. Yeah, button, 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 we get it. We're talking about a button, fine. But what's more kind of weird here is this dismiss argument. When we were defining the function, it made it seem super logical that of course the parameter is going to be called dismiss. But here we don't really know what is this dismissing. And if I wasn't the person who wrote this code, it may look super confusing. And we can end up in situations where, again, we are using the API in a wrong way and it's not what we intended. So how can we fix this in this situation? Well, first off, we're going to do what happened in Swift in the standard library, and we're going to remove some verbosity. We're going to get rid of that button name from the method name. So now it's just called add, and it just takes a button. And then if we update the call site, we can see that we have a much nicer call site now. It just says action sheet add button, much nicer. But there's still this dismiss boolean there. We need to do something about that. What are we going to do about that? Well, let's just remove it. Who needs it anyway, right? Let's just get rid of it. Well, I wish that was that easy. But we should get rid of it. And what we should do instead is just add an explicit API for adding a dismiss button. That way it's super duper clear that you're either adding a button or you're adding a dismiss button. So now if we update the call site, again, we can see that it's so much nicer and so much more conversational and easier to understand for anybody who reads our code. So now it just says action sheet, add dismiss button. Very easy. So, I think that great APIs, they should be conversational. They should make their intent clear by using more readable declarations. You should be able to read it just like a normal sentence. You shouldn't have to decipher it. It also eliminates a lot of cruft, and you also make usages more obvious, which is really nice. And by defining separate APIs for separate actions and separate functionality, instead of trying to cram everything into one method, we can create APIs that are easier to read and harder to misunderstand. And that is kind of the goal of code in general, right? Is to make things that are easier to read and harder to misunderstand. So that was characteristic number 2. Now let's move over to number 3. What hides behind this cryptic symbol? Well, what hides between this cryptic symbol is a buzzword, scalable. Well, everyone's always talking about scale, right? Whether you're talking about your team size or your server capacity or whether or not you can use Xcode in your company, everyone is always talking about scale, right? So why am I also using this buzzword here? Well, let me explain myself. And to do that, I want to take you kind of a little bit behind the scenes of one of my open source projects called Wrap. Now, Wrap is a JSON encoder that I originally wrote in 2015, about 2 years ago. And back then, encoding JSON in Swift, for those of you who were writing Swift back then, was kind of tedious because we didn't have the encodable protocols from the standard library. We didn't have much in terms of code generation and things like that. So a lot of apps contained methods like this one. Like you would extend your models and you would just implement manually a serialized function that took all your properties and just encoded them into a dictionary. Now, not only was this really boring to write, it's also extremely error-prone because we had to always remember to update the serialize function every time we added a property or we changed something. And it wouldn't always cause a compiler error because, it might just be missing from this dictionary and cause really tricky to debug problems later. So a wrap was an attempt to solve this problem in a nicer way. So my kind of vision with this project initially was to create this super simple function, which is called wrap. You could give it any object or any struct, and it would just return you data. And it would use Swift's reflection API, which is read-only, but it does exist. So it has some reflective capabilities. And it would just look at your object, look at the properties, and just encode them completely automatically. Now, not only was this an extremely simple call site and extremely easy to use API, the implementation of this function was also really simple. here was what it looked like. It was just a simple function called wrap. It would just take any object of any kind, we call it t in this case, and would either throw or return data. So super simple. So while the idea was good to have a very simple API that was very easy to use, it didn't scale. You see, here comes the buzzword. It didn't scale very well to more advanced use cases. So as I was starting to implement this library in different apps that I was working on, I found myself constantly hitting the wall of this API where I couldn't get any further. And I wanted to add more overrides or use things in a more custom way for certain types of objects that the app required. So what I started doing as a response to this was just to add more parameters to this function. So I had original just wrap object, but now I added a key converter where you could change JSON keys, you could override property names, or you could even ignore property names completely if you wanted to. So this brought a lot of power to the API user because you could now customize things as much as you wanted, you could ignore things, but it also generated so much more cruft because you had all these extra parameters, and I constantly found myself, daydreaming back to this beautiful API that I had in the beginning, and I really wanted to get back there. And this is where scalable API design comes in, where we should make sure to have our APIs scale from this very simple use case all the way to the most customized, powerful use case where you can add overrides and change the default behavior. So how did I accomplish that for wrap? Well, I started by not adding everything as parameters to the wrap function, but instead moving things into the type system. In this case, I created a protocol that I called wrap customizable. Now, the name of this protocol was very intentional because I wanted to make it clear that this was something you could conform to in order to customize things. So if you're not looking to customize things, you just want the simple use case, well, you can just use the wrap function as it was. You don't have to worry about this protocol. So it becomes a lot more clear. And then I added all these things that we had from before, like customizing the key style, customizing the wrapping itself, and ignoring property names. I added all of that to the protocol, so it was all on the type system, on the different types, instead of having to be at the call site, which is much nicer. But protocols, they also come with different trade-offs. And in this case, one big problem was that in order to just pick one thing that you wanted to customize, you had to implement all of this protocol, because a protocol is a very strong, clear API contract. And that was kind of not what I wanted either, but thankfully, Swift has a solution to this problem, and it's called protocol extensions. So what we can do now in Swift since Swift 2 is actually extend our protocols to provide default implementations. And this is something I think is a little bit underutilized sometimes within our own apps, where we can more think about powerful defaults that we can add. So in the case of wrap, what I did was that I implemented all of these different customization APIs, and this is where I put the default. This is good in a couple of different ways. First of all, it enabled you to only pick one thing if that's what you wanted. You didn't have to implement everything. But it also enabled me, as the person writing the framework, to kind of dog food my own API. Because now the defaults would be here right in the protocol extension. They didn't have to be hard-coded inside of the framework itself, which was a really nice benefit. So now, it was super easy to just extend user, for example, and change the key style. Here we're just converting to snake case instead of camel case, which was the default. But moving things into the type system is really nice, but not always possible. Sometimes you need to supply things at the call site. So how can we handle that in a good way as well? Well, what I wanted to do was that there were two different things I wanted to add at the call site, which couldn't be anywhere. Some kind of context that you wanted to supply when you were encoding your objects, and also if you wanted to use a custom date formatter, that needed to be the call site as well. But thankfully, Swift has a solution for this too, and it's called default arguments. What we can do now is we can add default arguments to our function signature, which again serves as the defaults. This is nice because it's very self-documenting. It shows what the actual default is right there in the function signature. But it also enables us to automatically get all these kinds of different overloads of this single function automatically generated by the compiler. We don't have to write all of them, we get them for free. So we still support the very, very simple use case from initially, where we can just say try wrap on any object. But then we can scale it up and add more things as we go to support all kinds of different use cases. So, I think that great APIs should be scalable. They should be really easy to start using. You should just be able to jump right in, start implementing it on your objects, and go from there. But you don't want your APIs to turn into this wall or this black box where it's impossible to do some things. Instead, we want to make sure to add overrides and be flexible enough to support more advanced use cases. We can do this easily using both extensions and default arguments, so that way we can easily provide a default without having to clutter our own code. And we can move things from the call site into type definitions and into the type system to enable them to be defined once, compiled, and then we don't have to always supply the same information at the call site, which is super nice. So that is tip number 3, or characteristic number 3. Now for the last one, we're going to talk about that great APIs are always evolving. Now I'm sorry if there are any React Native fans in the audience that thought this was going to be about React Native. Sorry to disappoint you. It's not about React Native, but instead it's about how we can evolve our API design. So what do I mean by that? Well, when we start out writing our app, usually it has a very small feature set. We want to make sure to ship some form of minimum viable product and then go from there. And as our app is evolving and as our product is evolving, so needs our code to be. It also needs to continuously evolve. Let's take a look at another example. Here we have a very simple function. It's called %profile, and it enables us to present the profile view controller from before, and if we want to do it animated or not. So very standard, we just have an animated boolean there. And this might be all that we need for a 1.0 release of our app. So we ship that, it's all good, it supports all the different use cases that we need. But then things start to happen. Maybe we start to hire more people, and these people come in with different ideas. Maybe we add new features, and this %profile function needs to support those new features. Maybe we have designers that come up with some cool new animation curves and animation things that we want to try out, maybe do some A/B testing and that the cool kids are talking about. So what can very easily happen is that this beautiful, simple little innocent function turns into this monster with lots of parameters and lots of things going on. And that can be kind of complicated, and it can make us end up in a kind of tricky situation. And also, if we start looking at this function here, we can see that we actually have quite a number of inconsistency. For example, we can both say animated false, but then also supply an animation curve. That doesn't make any sense, does it? How can we animate when we're not animating? And also we have this show friends that just shows up here for no reason. I don't know, why is that there? And what does that even mean, show friends? So it's kind of out of context, and it was clear that it was just added, like bolted on top of something else, rather than be there to begin with. So a really important thing to remember is that even if we spend a lot of time up front and we go, and think about API design and we come up with the most brilliant, sophisticated solution, it's only gonna be a sophisticated solution and stand the test of time if we continuously evolve and maintain it. So rather than just tacking things on the function and just adding more and more and more parameters to support new features, what we can do instead is split things up. So what we're going to do in this case is we're going to take everything that has to do with animations and we're just going to move it into an animation structure instead. It acts as a kind of configuration object where you can, if you're using an animation, you can just set everything up here. It's very clear and it's very contained. Then we're going to take this show friends boolean from before, and instead of having it just randomly in some function, we're going to move it into the profile view controller itself. Again, it makes more sense because the profile view controller probably needs to know about this anyway, because that's the view controller that's going to show the friends anyway. So it makes more sense. And now we can actually change our function to be a lot nicer. Instead of having this monster with lots of parameters, we can still have it be very simple. We can just call it %. We can enable us to give a view controller and an animation. And here you can see we're actually using all of the previous 3 characteristics as well. We have default arguments, which enables us to create a scalable API. We have made more contained APIs because things are now moved into separate types instead of being just in one big blob. And we have more conversational APIs because we can read this function in a nice way, %profile view controller with animation. So things are a lot more clear. So when you hear things like this, and when you come up with ideas on how to refactor things, and if you come back on Monday to your app and you want to apply some of the things maybe you heard about in this conference, one thing I think is really important to keep in mind is backwards compatibility. And this is something that is sometimes a little bit overlooked when we're talking about our own APIs. We're very, very careful about backwards compatibility when we're making some open source project because we don't want to break like 1,000 different apps. But when we're doing our own API design in our apps, sometimes backwards compatibility can be like dismissed a little bit, like who cares? Who needs this to be backwards compatible? Well, I really love backwards compatibility. I think backwards compatibility is beautiful. It's amazing. Best thing ever. So what do I mean by that? And how can we achieve backwards compatibility in a nice way? Well, what we're looking to do here is we're looking to go from this big, monstrous function from before, this percent profile with lots of arguments, into this more nicely streamlined version that we're looking to migrate to. How can we do this in a way that's backwards compatible? Well, what we're going to do first, we're going to start by doing what Apple does whenever they do something like this. When Apple changes an API in UIKit, for example, they don't just rename the function. That would be kind of super frustrating to all of us that our app suddenly just breaks. What they do is they use deprecations. So what they do is they deprecate the old function, and you can do this yourself. You can add this available attribute to any property, method, class that you want, and then you can give it a renamed function name. Now this is very nice because this might look like a string, like you're just passing a string, but the compiler actually checks this string and actually generates these nice warnings for you. So you can see, just like you would if you open your app with the new iOS SDK and you see these deprecation warnings, you will see that in your old code as well. Now what this enables you to do is more migrate to a new API that you've designed piece by piece instead of having to refactor the entire app and submit a pull request that is like 5,000 lines changed, which will probably cause some regression. Now you see here, if you're looking closely, you might see that there's even this nice fix button here, which looks really cool. It's like, do I get fix it for free? Like I just click this button and then everything just updates? Well, it's Xcode, so of course it doesn't. It doesn't work. But it would be nice if it did in a future version. So this is step number one. We've now deprecated API, and we have signaled to all of our coworkers and to our future self that this API is deprecated. It has a new version of it that you should use instead. We can go even one step further. Instead of having to use both implementations and keep both implementations around, which kind of is annoying to have to maintain both of them. What if there's some bugs in the old implementation? That would be kind of annoying to have to keep those around. So what we can do instead is we can actually refactor the internals of this API. We don't have to change the external version. We can just change things under the hood. And what you can see what we do here is we're actually just calling our new API from within the old one. That way we have maintained backwards compatibility. We can make a very, very nice small change that is much, much less risky. We can improve the old implementation without having to break all of our app. And we can migrate to it in a much nicer way. And again, it's a little bit about dog fooding. If we can support the old use case, well, that's going to be much nicer and easier to migrate to. So I think that great APIs should be constantly evolving. They shouldn't just be designed once and then forgotten about. You should kind of maintain them and make sure they are kept up to date. And rather than just growing in scope and complexity by just keeping adding things to the same function, what we should instead do is to refactor things and break them up into separate pieces. That way we can make things a lot easier to maintain in the future. And backwards compatibility is a really beautiful thing. I think it's really awesome when you can make something backwards compatible. And it can easily be achieved using deprecations, or if you're just making additive changes. If you can make an API still work as the old use case, but still just adding things on top of it, that can also work in order to maintain backwards compatibility. It's going to be so much easier to migrate to. So, to sum up, we've talked about 4 different API characteristics today. Contained, where things are more contained in of themselves. They don't leak implementation details all over the place. And they become a lot easier to refactor and change because they're not spreading all of their things all across an app. They are in one place. Conversational, where things are easier to read and easier to understand by becoming more an English sentence, and more clear. Scalable APIs, where we can scale things from a very simple, easy use case that is just like one line of code to a really advanced use case that supports everything that we need to do. And evolving APIs that are constantly changing as our product is changing and as new things come out that we want to support. So that's all I have for you today. If you want to keep in touch with me after the conference, I'm here both today and tomorrow. So feel free to grab me and ask any questions that you want. But you can find my work that I do online. I'm on Twitter. I'm at John Sundell. And I run a weekly Swift blog and podcast on swiftbysundell.com. Thank you very much. All right. Does anyone have any questions about APIs? Give me all your tricky questions. Yes, there we have one.
So, do you still have a code police to support all those
the code police?
Yeah.
No, he retired. The code police retired.
So, each developer in your team writes code in that way?
Yeah, so we're a very small team where I work at Hyper. We're only 4 iOS developers. So what we do is we try to really share standards and share practices with each other. So if someone finds a new pattern that they think is good to use, we try to, bring everyone on board. Before I was working at Hyper, I was working at Spotify, which was a much, much larger team. And there we also tried to share best practices, but there we are using a lot more like style checkers and, linting and things like that, and more focus on CI to kind of not necessarily just enforce things, but to kind of encourage best practices, right? So I think there kind of needs to be a little bit both, depending on your team size. There could be just both the make sure everybody knows kind of how to do things, but also making sure you have like static checks and tests and CI to ensure that things are working in a good way.
Yes, thank you.
Yeah, no problem. But don't rely on just the code police, because eventually he's going to be retired or on vacation. Yeah, any other questions? Yeah, I think over here.
Thanks. Great talk, John.
Thanks.
Quick question, and it's more about the personal attitude and the team attitude towards documenting your code. Because right now in Swift we have this beautiful header documentation written in Markdown.
Yeah.
So does it make sense to actually document the code? Well, you focus a lot on designing API the right way.
Yeah.
You maintain it. You spend a lot of time on it. But adding header docs, what do you think? You have to maintain them as well, but on the other hand, you've got this beautiful pop-up with everything, like describing everything, and, well.
Yeah, it's a great question. I personally love documentation. I think that documentation is great, but I think we need to use it in a way that makes sense. So one thing that sometimes I've done in the past, and I've seen other people do as well, is that you just document things literally. So it's like you have a parameter called animated, and your documentation is if it's animated, right? That kind of, okay, you could understand that anyway. Like you don't really need the documentation for that. What I think we should use documentation for is all the kind of nuances of the API that are not clear from just reading the signature. So if I have something which is like cache, true or false, like how long does it cache for? Like what does it use for the cache? Like just all the details, because what we're always looking for is that I shouldn't need to jump into the implementation and read the implementation to understand how an API works. It should be clear both from the signature itself, and if that doesn't provide all the context, because you don't want to end up with tracks metadata for video, for connection, you don't want to put your entire documentation in the function name. I think documentation is a great complement to that as well.
Cool, thanks.
Yeah.
Thanks. I have one question about deprecating old things.
Yeah.
Do you have an experience with Objective-C migrating to Swift? Is
Yeah.
there any good advice how to do that?
Yeah, so another great question. So what you can do there is that, first of all, the number one thing is to make your Objective-C code nice to use in Swift. So you want to do something similar to what the Swift standard library did. And there are other annotations that you might have already explored where you can say that this method here is going to be called this in Swift. You can actually override what it would be imported as in Swift. And I think that can be really nice because that way you don't actually have to deprecate things or change things, but you can just make them import nicer in Swift. So your Objective-C code doesn't have to become Objective-Swift. It can still be Objective-C, and then your Swift code can still look and behave like normal Swift code. But sometimes you do need to deprecate things and move on. And for that, I think a nice way is to use wrappers. So you could have a Swift wrapper on top of your Objective-C code where you use that within Swift, and that can have all the Swift native functionality, like enums, structs, all that kind of good stuff. But you can still maintain the backwards compatibility with Objective-C by using like a shared core implemented in Objective-C. Yeah.
Okay, thanks.
Yeah, you're welcome. Yeah, there's one up there. Great questions.
So on the beginning, you had this protocol of database with the generic type.
Yes.
As we knew, in Swift, there is only associated types in the protocols, and sometimes it's a pain in the ass to maintain that.
Yeah.
Have you met that, and how you handle that?
Yeah. So definitely be careful with associated types. It's you can easily end up in a situation where you have an associated type on a protocol, and that prevents you from using it as a concrete type because it has self requirements. So you have to always use that as a generic, and you just have generics and generics and generics, crawling all over a code base. And then eventually your app delegate is a generic, and you're like, what have I done? You don't want to do that. So again, containment is a really good thing to do here, where if you need to have something have associated types, make sure it's contained. And you can use wrappers to kind of type erase the protocol a little bit. I have a blog post about it. I can link it later, where how you can use type erasure in a nice way to have a non-generic interface to a generic protocol. But yeah, sometimes you need to use generic associated types. It can be the best way to do something. But I would say definitely be careful about it and try not to make it leak too much outside of the abstraction. That would be my recommendation. Yeah, up there.
Hi, I have a question regarding the documentation question, so small inception. I
Nice.
believe that you have a bit experience with the writing documentation by working at Spotify, now at Hyper, with a different size of a team.
Yeah.
And you also said that you like writing more detailed info next to the APIs. And I wonder if you have any good practices in syncing that with actual code, because sometimes I just think that maybe if you write so much details, then they tend to derive with what actually happens in the code.
Yeah, that is a very common problem, right? And I think, it would be super cool if someone is looking to write a developer tool that checks that documentation actually is, correct by evaluating the implementation. But I think that can be really tricky. Maybe that's a case for core ML or something, like machine learning on the documentation. But in the meantime, I think keeping the documentation simple and not relying too much on concrete types. Like, for example, if you are taking this animation structure, instead of always referencing that structure, because if you then change the name of it, the documentation is not going to make sense anymore. Try to write the documentation more about the behavior, because chances are if you don't do the thing where we just tack on new functionality to an API, if we keep the API doing the same thing and just evolve it, chances are the documentation is still going to be relevant even in the future, because it was just documenting the behavior rather than the actual concrete types that were used, and then moving that documentation into the types in themselves, if that makes sense. I think that is a good approach in general.
Yeah, thank you.
Yeah.
Just correct me if I understood you wrong. I mean, regarding the infos like animation time or the caching duration, should we avoid those, or?
It's good, I think, to document those behaviors. So, for example, if you're caching for 24 hours, it can be very good to put those things in the API docs anyway. But of course, then you have to remember to maintain it. So it is always a tricky trade-off between giving enough context in the documentation and making sure it doesn't go obsolete.
Yeah.
It's tricky, but I would suggest just try to have a culture in the team also where if you change the implementation, always look at the documentation also, just to, you know, try to avoid those mistakes, and then keep it simple.
Sure, thank you.
Yeah. Well, we have 20 more seconds. Anyone has a question in 20 seconds? No, okay. By the way, if you want to ask me any more questions, you can both catch me, you know, just come up to me. I love to talk to developers, so just come up and ask me any questions you want. And you can also submit questions for my podcast, where I answer questions from the Swift community. So do that if you want as well. Thank you very much.